Hello, my name is Samuel Chang and this is my Lab 3, Magnetic Field of a Bar Magnet. In this lab, we were given a small bar magnet to measure its magnetic field. The overall objective of this lab was to 1. Find and calculate the distance-dependent exponent of a bar magnet as well as its magnetic dipole, and 2. Use GlowScript to visualize and compare the calculated perpendicular magnetic field with the coded magnetic field. In this lab particularly, it's important to understand behaviors of magnetic fields by using the derived equation from Biot-Savart law to produce the following equations, as well as the idea of superposition that at a certain point, magnetic fields can be added together. After going to the lab, the distance-dependent exponent that I got was around 2.5, as seen by the data. The closer you get to the bar magnet, the magnetic field increases as suspected. These are the results for the off-axis magnetic field. Using the graph earlier, we can determine the magnetic field moment using the following equation. ln of B equals ln of K plus n times ln of R. We use this to find the distance dependence earlier in the graph. After setting R equal to 0 to get rid of the n times ln of R, we can solve for K. After some simplifications, we get that the magnetic dipole moment is 5.795. And this is the code for the lab. At the bottom, you can see that I use the following code block to calculate the magnetic field at a certain point, which will be used throughout to find the magnetic field at certain axes and perpendicular areas. This is a visual representation of the magnetic field of the bar magnet. You see that outside of the bar magnet, the magnetic field points to the left, whereas in the middle, it points to the right. The computed value of the perpendicular axis magnetic field ends up being 1.6101 times 10 to the negative 5 in the x direction, 4.83029 times 10 to the negative 5 in the y direction, and 0 in the z direction. My actual value goes out to be 1.133 times 10 to the negative 5 and 5.1867 times 10 to the negative 5. As you can see, the data is pretty close. If we had not oriented the experiment to compensate for the magnetic north, the bar magnet and the magnetic north would have superimposed and would have messed up the data. If we were to stick two identical magnets together, again according to superposition, the magnetic fields would increase.